the next session that we have is on open source satellite data, and the session will be jointly taken up by Dr. Priyabrat and Dr. Pooja. You already have met Dr. Priyabrat. Let me quickly introduce Dr. Pooja, who is a postdoc fellow at University of California. She holds a PhD with special. Could I please? Sorry,
But I also do Pentecost sometimes.
sorry. Um,
I think that
Larissa,
was Dorica again. I already mute her
Yeah, even I'm
microphone.
seeing that people have opened their mic. Okay, so yeah, so Dr. Pooja is here who will be jointly taking session. Um, so I was telling you about Dr. Pooja. I'm so sorry. She holds a PhD with specialization in remote sensing, and well, you have a total of 60 minutes for the session, both Pooja and Prabrat. You can split it among yourself, and it's 4:50. I will be giving you a heads up by 5:35 to help you keep track of time. Over to you, Pooja and Prabrat. You can share the screen and start interacting with the participants. Take the session the way you would like to. Uh, Pooja, I would also request you to switch on your camera. Prabhat, if you can also switch on your camera, it would be great.
Okay,
All right,
okay,
yeah.
okay. Thank you very much. And also my co-partner for this session, Dr. Pooja has already joined from very early morning in USA, but she woke up and be ready to join in this session. So Pooja, just I am starting now, as we talked earlier. Yesterday also we talked. So first few slides, maybe up to 18th slide, I will talk on for around 25 to 30 minutes. Then I hope we will cover the rest part for another 30 minutes. Okay. So I am now sharing the slide for open source data uh, availability. So first I will check whether these slides is visible to everyone.
yes.
Okay, thank you. So this data, open source data, and this is the most talking point, and this is the most powerful tool we have at this moment, which was not there 10 years back. So whenever we are looking for some special data to do some analysis or do some future work for our research purposes, these data were not so available in abundance. But if I look on websites, flood of data is available, whether it is a spatial data or whether it is a non-spatial data. So in this session, myself and Dr. Pooja will try to give you exposure to different type of spatial data available freely in the website, in the IT platforms. So we have compiled several open source databases, their links, and I will explain, and where the remote sensing and GIS data products are available, both international and some national databases also. And I hope this is only minuscule of this presentation, because at this moment there are huge amount of data available at global level and national level and regional level also. Then how to create profiles to get access of this data, some of the for research purposes, not for commercialization purposes, use it on its own, and how to access and view this data, how to search data, and how to download data. All these things we'll cover. So first few slides I will cover, then Dr. Pooja will cover the rest portions of the slides. So pattern of this presentation is more or less same, because I will give one example at one slide. What is the data available? For example, this is natural earth data. Natural earth data, and every slide at the end there is a link given, and if you click on that link, it will open to the that portion. So just I will give one example here. Suppose this is a natural earth data. If I click on it, this natural earth data, it will be open. And if you go through it, you can see a lot of data are available, and you have to go to this download section. In download section, you will see some announcement list has been written and what type of data are there. So large scale data, medium scale data, small scale data, it is available. So if I check it once, that in large scale data, there are three subcategory: cultural data, physical data, and raster data. And these data, the most detailed, suitable for making zoomed in maps of countries and regions, show the world on a large wall poster, etc. So it is 1 centimeter is equal to 100 kilometer. So if I click on raster, so whatever raster map is available, it has been given. Natural earth, cross blended hypsometric tints, natural earth 1, natural earth 2, ocean bottom, shaded relief, gray earth, manual shaded relief. So all these databases are available. Suppose if I click on natural earth, then it will go this natural earth, this large size databases, medium size, every options has been given from where you can download these databases. Then I will go to the next part, OpenStreetMap. So this is now most of the people are using now in their smartphone everywhere. We are using this data most of the time for our traveling purposes. Wherever we go, we just type in the Google, and this is actually in the background search or using the OpenStreetMap data. So this OpenStreetMap, if you open, so for the global level, this data is available. You can see for everywhere, you can see lot of data are available. And at the right side, you can check these boxes. Here, different layers, whatever layers are available, it is there. Suppose this is the standard layer available. If I click on the cyclo-SM, so this portion is available. Then cycle map, then transport map, then trace track topo. So all these things are available in the OpenStreetMap. And you can access these databases by using the export option, and you can download this data through some exchange and using some license file, and using your own area you can define here, and you can access this data. Next I will go to the ArcGIS Hub. So this is another very good GIS data domain where administrative and political boundaries, environmental data, cultural and historical data, satellite and aerial imagery data, economic business data, demographic and socioeconomic data, all these things are available. And these data are mostly now accessing through Google Earth Engine. We are not talking about Google Earth Engine in this course now, although all these open source data are directly accessed by Google Earth Engine. For example, if I click here in ArcGIS Hub, so you can check what on your own on every website, and you can make your own login and check what are the data available in these places. So suppose this example, it is a Georgia Department of Transportation. It has provided some data. So if I click on this data, then country road, Morningside Drive at Millie Creek, Leak, Lock Creek, all these details data are available. But likewise, everywhere you can check that what is the data available in that website, and you can see the gallery templates and data portion, what are the data available, apps and maps, everything you can check, and you can download on your own from this. Suppose here if I click on administration data, so it will give the administration data. If I agriculture, it will put some agriculture data, the administrative data. So likewise, you can check all the requirements. Suppose here also I can do some filter with license. No license is required, and for this data, this type of data are available. Next, we'll go to OpenAerialMap. So these actually data types of aerial imagery, satellite imagery, drone imagery, historical aerial imagery, elevation data, and thematic maps. So if I open to this, suppose start exploring, you can explore that what are the open aerial maps available. So in the whole globe, you can select your own area, and you can check that what are the data available. So here I am seeing one data here for this portion. So it is written OpenAerialMap is a set of tools for searching, sharing, and using openly licensed satellite and unmanned aerial vehicle imagery. Okay, so all these data sets are available here. Now next I will go to the global climate monitoring (GCM). So it is giving the data on atmospheric data, oceanic data, cryosphere data, terrestrial data, climate models and projections, extreme events, air quality, remote sensing data. So likewise, if I also go through this part, this global climate monitor. So this you can check that what are the data available through some maps. It will be shown. I will not go for survey now. So this is the, here you can see it is the monthly rainfall data it is showing. So if you click on monthly temperature, so this is the monthly temperature data in the month of February. Likewise, suppose in the month of July, we are in this. So please select a proper year or month, because it has not been prepared now. Because we are in the current month. So likewise in 2023, if I click on July month, so it will be prepared. And here, from here we can download a point, download a bounding box, download a country, complete map. So whatever you want to download, you can download from it here. And here is some climatograph, histograms, monthly, annually series. So a lot of plots also have been given. Suppose click on map point. Suppose if I click on here, so here some maps will come, annual temperature anomalies. Okay, in this portion. Suppose if I do it on Eastern India, so this is the anomaly, it will be loaded here. So interactive plot also you can see in here. So I will not spend much time on this. You can play on your own. So this has annual temperature anomalies near 9023. So this latitude longitude is around 9023. Okay. So likewise, precipitation also we can see. That is the precipitation, and it is 10-year smooth moving average. So all these anomalies has been given. So instead of getting the analyzed data, you can get also analysis of the data on a spatial scale from these websites, Global Climate Monitor. So these are very beautiful tools have been developed in recent times. So this is another OpenTopography. This is leader point clouds, digital elevation models, global digital elevation model, topographic and bathymetric data, ancillary data. Lot of data are available in the OpenTopography sections. Suppose it is opening, and suppose here you can do a select a region. Okay, suppose if I do it in where you can do in suppose Morocco, I want to see Spain, France, Morocco is here, and select a region, click. So all this data it will show that high resolution topography, then Copernicus global data, global bathymetry, whatever in that region, whatever data is available, we can see it. Suppose satellite topography mission global data, if I click on it, so this data is now available for that period. Download and access product. So now we can download this product from here. So you can see lot of opportunities to download different types of spatial data. Now NOAA data access viewer. So it is a coastal LiDAR data, satellite and aerial imagery, hydrographic data, shoreline data, elevation data, oceanographic data, environmental data, and meteorological data. So most of the time we are using a NOAA site for using the spatial meteorological data. We can go to this website and we can check that what types of data are available. So this is the digital coast data access viewer in the NOAA. So for example, this is in United States. If you go to these portions, India, then this is the actually land cover. If I put an elevation, it will give some change of this data. Then we can search by address, lat long or extent, or we can draw as I do in my spatial analysis that this draw how it works in the background. I have already shown. So it has been displayed that oh no, there are no results that match area of interest. So that means data is not available for this position. So this coast data is available only for this area. If I click here, so it will put some coastal data. So wherever it will be available, it will be shown. So now we will go to the European Environment Agency data, which actually give lot of data related to environment. For example, air quality data, climate change data, water quality, biodiversity and ecosystem data, land use and land cover data, environmental health data, natural hazards, sustainable development data. So you can see the opportunity. It is the flood of data available, and a lot of people. That's why now started working on the metadata analysis because all these data are available now. So which was earlier not accessible to anyone. And I hope everybody has aware of the global open data sharing policy because every countries have joined together is in a global platform led by United Nations, UNGICC, United Nations Global Framework on spatial domain, something it is written. So in that collaboration, actually it has been developed that data sharing, data policy and putting is in open access domain. So this is the data hub. So where we can lot of data, suppose the Copernicus data, I think Pooja will handle specifically on this data later part. Then statistical data, some data are available. I'm not going into the detail, but I am showing only the glimpse of every website. And here it is a global, self-consistent, hierarchical, high-resolution shoreline data. So here actually mainly the people who are working in the ocean, shoreline, this bathymetric data, they can access this website for accessing or downloading some of the data which is of their own interest. It is also cited in NOAA site, National Centers for Environmental Information of the NOAA. So it is the global relief model and grid extract, geotip format, 15 arc second resolution, all these bedrock elevation, 60 arc second resolutions, net CDF data. Just you have to go through at different websites and you can check that what are the data available. I suggest you to better make a document where all these data are available and make a document where it is available to you at any time and you can check every type of data from those places. And next, I will go to global this digital elevation model data. I hope everybody has access or tried to access this type of data, because this is the elevation data is mostly downloaded data, and it is available in Earthdata website. Just I am clicking on every link to show you that whatever link I have given or Dr. Pooja has compiled, all the links are in active condition, and you can download from anywhere from this web platform or web search. You can see what type of data are available here also. So, for example, if I measure showing the instruments, so what are the different instruments have been used, and suppose I want to download a data which is acquired by Moody's satellite. So here I can filter it. So here all this Moody's data will come. Okay. Suppose I want to sort data we want to collect. So whatever synthetic aperture data, it will be shown here. And likewise, any instrument, whether it is a leader or whether it is ATM plus of Landsat, whether it is AVHRR, so all type of data are accumulated here. Then Earth environment DAM data. Most of the time you can also find that some of the data are available in multiple locations or multiple data platforms. So any of the platform you can download this DAM data, because DAM data is available in most of the open source data platform, whether it is a CSIR, CGIAR, SRTM data, or it is a EarthExplorer data, everywhere it has been given. For example, here, if I want to click a data for this place, so maybe it is not working now. It is not a security reason, it has been blocked. Otherwise, you can put it some decimal values here. As I run through code, if I put your extent here, minimum, maximum of latitude and longitude, you can extract the data. Then NASA power, which will provide the solar radiation data, climate data, then some derived data. It is also available here. And one of the most important feature or every open source web platform or data platform, here we are seeing now this graphical representation of the data. To check it or initial analyzing in the open platform itself, the quality of the data variation, then only you can download. No need to download every time. You first check your data's behavior or visualize the data, then only you can download the data. Some global level data, regional level data, single point. So a lot of options have been given here, where you can go through and check your own data. Then some of the Indian data in the India bodies, there is a water resource information system. So this data I often use for my own research purpose, where most of the groundwater data are available. So here also we can, for example, if I keep on this water data in surface water, you can see different types of river data, storage data, snow, glacier, lake, surface water quality. Then in case of groundwater, we can see that groundwater resource estimation, groundwater quality, water level behavior, all these data are available in the India bodies. Groundwater resource estimation, groundwater prospect study, groundwater quality. So then it will go to the another platform where you can see different types of availability. And there are also some tools available in this website. from where you can use some of these tools. Suppose so you can see these are the CGWB wells in the country. In the India, Central Groundwater Board has maintained lot of wells where this groundwater is being monitored. And here we can see some of the graphical representation, number of monitored stations, number of active stations in last 10 years. So all these informations are available here. Okay. So this is an very good information tool available in India, and similarly in the BHUCOS, which is a geological survey of India. There are also some geological maps are available, which is some of the maps they have made to public. So this is the BHUCOS gsi.gov.in. So here if you click on any some geology map, say you want to, so you have to make a login here, and you can search your own map and you can download. And then we go to another website of India, which is a ISRO developed site, VUNIDI, ISRO's Earth Observation Data Hub, where we can get data on the land resource, water resource, climate and meteorological data, agriculture, geospatial, everything. So here also we can go, and likewise we can download the VUNIDI portal and try to get some amount of this polygon, shapefile, all these data we can download here. I think there are so many things in every portal to explore. I am just quickly going through at different sites so that it will be a eye-opening to every participant that this much of data are available at this present moment. Then Giovanni, which is Earth data, it is maintained by NASA, where also get a lot of special data sets of different Earth features and atmospheric features. Here, the slogan of this website, you can see geodata, the bridge between data and science. Because capturing data, and if it is not shared to anybody, then it has no meaning, because it is now becoming a dump. So earlier you have to use those databases. So here we can see at different disciplines, they have provided different types of databases, and model data, observation data, and reanalysis data. Every group they have provided the data. So you can go through of it, and you can search at different platforms. Similarly, the Bhuvan platform, which is a very popular web platform for Indian satellite data and any type of land use, land cover data. So here you can select different Indian satellites, for example, OceanSat, Cartosat, ResourceSat, all these satellite data, or some theme products you can also choose. For example, land and terrain. Then we can choose, suppose Cartodem all version. Then we can see this type of data are available. So here you can see the bounding box. If you can give some values, so for that portion it will download the data. Okay. So I already completed 30 minutes time, I hope, and I think it is in the right time. It is in the break. But before breaking, just I will go another example of the live spatial data for a. So if I think you have already checked it, most of the people, but I am showing it again to see the current situation of the earth real time, 3 minutes 3 hours delay. So this is another data, but it is not the downloadable data, but only the visualization part. uh, every time it is very fascinating to see what happens in the earth, whether it is a cyclone, whether it is a precipitation event. I can just go through on my location and I can check whether any phenomena is occurring here. Suppose now it is in the Arabian Sea, there is a phenomena occurring. The temperature wind movement is towards in the eastern direction. So if I click on everywhere, I can click what is the wind speed and direction. So there is a high wind speed at this Bay of Bengal, which is around 51 kilometer per hour. So something is happening in this part, and I can check in the whole globe that whether it is a any other cyclone movement is there or not. In South Africa, this part, there are some cyclone movement is there in these places. So you can check and you can click on this portion in Earth. There are a lot of data available. For example, this is currently showing air, wind, and surface condition. So this is the set I have checked. If I check on the very upper height, for example, 10 hectopascal height, what is the pattern of the wind? You can see there will be a lot of change. You can see now the high wind speed, it has been changed. And if I click, it is 117 kilometer per hour at 10 hectopascal. So at a particular point, you can check that what is the wind speed profile. Okay. And from this wind speed profile, you can guess that what is happening in those places, whether it is an upward movement of the wind or downward movement of the wind. So likewise, in case of there is also temperature, then relative humidity, then dew, then one is precipitation, total precipitable water. So it is given in terms of total precipitable water. So we can see whether in our cloud, whether it is a precipitable water is there or not. So here it is 50.4 kilo per meter square of air. The precipitable water is there at these places. So this is a useful tool, and I always try to check this website regularly for any cyclone movement and their movement pattern. So you can also try to check some of these sites for your own. So with this brief, I will hand over
Hello,
rest of the presentation to Pooja.
Dr. Priyavrat.
Yeah.
Yeah, so sorry to interrupt. Just wanted to say we are almost done. Or like it's 5:22 and we need to leave some time for puja. So
Okay.
may I request you to expedite the session? You can take 5 more minutes to wind it up, and then Pooja can take over from here.
Okay. Actually, Pooja will take the next session also, I hope.
Yeah, she will be
Yeah,
taking
she
the
will
next session
continue.
as well.
Okay. So
I mean, you can take 5 minutes to wind it up, and then for rest of the
okay.
presentation, she can take over.
Okay. So whatever websites I have shown here in the web platform, so now there is a huge opportunity to use this data, whether it is a spatial data analysis or non-spatial data analysis. Even in the R environment, you can do a lot of non-spatial analysis for your data. For example, if anybody is interested to do some this carbon sequestration study for the whole globe, or do some study on the conservation agriculture, whether it is effective at different portions of the whole globe. So a lot of data are available from different platforms. What you need to do is to collect all this data and reanalyze using this open sources tool. And there is another advanced version of this R environment. If anybody is very much interested on further study or further doing this analysis very quickly, you can always use the Google Earth engine. No need to download any data, no need to process every data. You just give a Python code on the Google Earth engine and it will access from all these platforms. So what you need to do in this Google Earth engine, you just give the website example and you give the data product I want to access from this website. So Google Earth engine automatically access those data and it will give as an input in your own art script or in the Python script, and it will analyze and it will give the final output. So no need to dump your desktop with a lot of terabyte of space required. Okay, so because one remote sensing data actually uses a lot of spaces, so no need to download your every time the data what you want. My submission is that you no need to download this data, because earlier we are scared that whether this data I can get it or not. But I think it will be sure that whatever data you think now it is accessible. whether it is from Indian platform or it is from NASA platform or it is from other European Space Agency platform or any other platform. Everybody is trying to put data in an open platform now. And in Indian condition, if I say about the Indian policy changes, in 2022, there was a Gazette of India notification of National Geospatial Policy. It has been opened. So as per those National Geospatial Policy, now in Indian government, we are also combining all this data. For example, Geological Survey of India or Survey of India is leading those activities for the whole country, and they are converting the 18 themes to convert this all this data to a open source data. Likewise, geology data, soil data, this road network data, this electricity grid data. So these data are now available. For example, once I tried to do some analysis on the this one analysis in GIS environment is very popular, which is called the AHP analysis. So in this AHP analysis, you can club all this data to get a decision about your national level mapping or regional level mapping. So with this background or information, I hope I have tried to do my best to expose you to different platforms. So thank you very much for your presence sharing, and I hope everybody will use this open source data once. So thank you very much.
So much.
Hi, Jinat, please. Yeah, please proceed. Jinat? Okay.
Brother, what is the plan?
So, yeah, I think Jinat may be off.
Yeah.
Okay, so no issue.
I was
Yeah,
viewing
Jinat
someone
is good. Okay,
else's
Jinat, please continue.
whiteboard, so I was just checking if a participant by mistake has put a whiteboard over there. Not an issue. Thank you so much, Dr. Priyabrat. We'll now request Pooja to take over the remaining part of the session, and the last session for the day will also be taken up by Dr. Pooja. So over to you, Pooja.
Thank you, Jeanette. So I'll take over from Dr. Priyabata. Thank you, sir, for
Pooja, just to understand, you will be winding up this session and separately taking the next session, right? You won't be clubbing the two.
Yeah. Okay. Just let me know because it's, I won't be able to just convert the timings.
Right. So the thing is that it's 5:30 already. We have 15 more minutes for this session. And then you can start off the next session after that. 15 more minutes for this session, and then your session, we have allotted a total of, oh my God, 95 minutes, which is a lot for you. So let's get done with 15 minutes. We would like to give the participants a break. They have been sitting here for too long. So we'll probably have a 5-10 minutes break, and then the last session will go.
Okay, great. So, yeah, I would, as Priyabrata sir said that like currently there is GE platform to actually just download and do your analysis. But in this section, we are separately mentioning all the data resources where you can have different types of spatial data. So one of them is Copernicus Open Access Hub. It is hosted by ESA, European Space Agency, and it hosts data from Sentinel-1 data, which is a SAR data, Sentinel-2 data, which is optical data, and the entire fleet of Sentinel data, which is like the STAR satellite data of ESA. If you click on the link, okay, if you click on the link provided on your PPT slide, it will directly take you to the data search platform of Copernicus. So here, what you can do is just select your area of interest. Oops, sorry, it's moving way too fast. Yeah, you can just zoom in and then you can just draw a polygon. And so here you can select which satellite data you want. If you want satellite data from Sentinel-1, you should select Sentinel-1. If you want satellite data from Sentinel-2, you should select Sentinel-2 data. There will be two types of Sentinel-2 data, which is the optical data. So L1C and L2A. L1C is actually is not atmospherically correct data. So you shouldn't directly use data. You have to first atmospherically correct it, which they have already done for you through L2A data. So you should select L2A data. And then from here, you can select your date. If you want to select a range of date for your data, you can do it from here. You can just select the date for which you want your data. They also give you options for like selecting a set of bands. So you can select like all these bands. If you want in DVI, you want your data to be in false color, so you can just select Sentinel-2 also has square bands, so you can just select square bands. So yeah. Okay, so I have not logged in, so this is not giving me option to download. Otherwise, it will straight up give you option to download, and you click on the image link, it will automatically download the image for you. I would move on to the next slide. Yeah, so USGS EarthExplorer is one of the most widely used data resource offered by the USGS in United States. It has all kinds of data ranging from Landsat, it has Sentinel data, MODIS data, it has digital elevation data, it has radar, thermal, and global survey vegetation and monitoring data. So to download data from USGS EarthExplorer, you can just go to just type in USGS EarthExplorer and it will open the search platform for you. So here, I'm already logged in because I have a profile already. Otherwise, you have to, for all the data sources that we are mentioning, you need to register first and then make your profile, and then you will be able to download the data. So once you create your profile, you can just put a search. For example, you want to download data somewhere in Africa. So what you can do is there are plenty of options. You can download, you can just select address and place, and you just type the address. For example, like Congo. Let's try. Yeah, okay. So it has given you, because it's just like not a very precise location. So it has already given you the lat longs of your search place. Then you have plenty of options, such as you can control the cloud cover data. For example, you don't want cloud cover on your satellite data for more than like 20%. So you just set this filter. Otherwise, you keep it as it is. And then you can put a date range, like, your starting date to your end date. So you put your date here, and then it will take you to, for example, I'll set a date. And then it will take you to the list of the data that are available here. So you can see that there is a Landsat data available here. There is collection 2, level 1 and level 2. There is a Landsat legacy also. So in legacy, you can find the older sensor data, MSS, um, thematic mapper. You can also download radar data from here, these from CERC. What else? Digital elevation, yes. You also have digital elevation data. So I am currently using GTOP 30 data, which is like a 1 kilometer, 1 kilometer DEM data for the whole, for the entire globe. So this is something very useful. Yeah, so once you select your data type, that this is the data I want to download, we have selected all the other parameters, date, place, and data types, and then you can just click on results. And oh, this not showing. Mm, okay. Mm, Something wrong with this. Let's select some other data.
Please check your end date for the selection of the dates. I think you had put a date that is not there, 17th of July.
Yeah, there's something wrong with the date actually. Okay, first I have to set it. It's 18. Instead. Okay. No, still. Okay, for example, let's select some other data. Let's select the Landsat data, level 1. This is just for demo. Okay, here you have like Landsat data for the polygon that you have suggested or your study area. So you can just like have an overlook of your where your tile is placed. And then you can simply, this is the download button, you can simply download it. It will give you a couple of options. For example, you can just download the entire bundle, or you can just download a set of bands, whether you want to download the thermal band from Landsat 8, sorry, or whether you only want like the basic bands. So you can just select and download for you. Moving on to the next, sorry. Next source is SRTM from the CGIAR data. If you click on the link here, so it will take you, redirect you to the CGIAR website, and they have a data ranging from 90 meter to 1 kilometer. So you can just go to the data, RTM data. It should, okay, they have provided a, oh, this URL is not working. Priyabrata sir, do you have any idea about why this link is not working? Okay. Guess this link is not working. I'll get back to you on this link. Um, Otherwise, for like 5-degree data, which will be around 5-kilometer data, you can just like click the tiles that you want to download and then go to search. And then it has like provided you the tiles that you have selected. So yeah, that's for the SRTM data from the CGIAR platform. Moving on to the next, world climate data. So WorldClim is a host climate data. So it is specially a website for the climate data. Anyone who wants to work on the climate data can download climate data from here. They host a climate data for the past historical times, as well as they have climate change projections from the ICC AR6, AR5. So if you just click on this data link, it will open the WorldClim website for you. This is a pretty easy website to navigate to because as I mentioned, it hosts historical, near current, and future conditions. So if you want to download historical data, which is from 1970 to 2000, it's a bit older, but it's just like, it's the average of these 30 years data. And it's mostly used in comparative study, like current versus future projections. So you have data available in different spatial resolution. The best resolution they offer is 30 seconds, which is around 1 kilometer. So you have data such as minimum temperature, average temperature, precipitation data. While their temperature data is very good, there is a little bias in the precipitation data, so that has to be used very wisely. They have recently added the additional BioClim plus variable such as solar radiation, wind speed, and vapor pressure. Usually I have been using the climate data for the bioclimatic modeling. For example, where you can find your plant distribution in current versus where they are going to be projected in future. So for that, we use bioclimatic variables. These are 19 different climatic layer, which are obtained using the basic temperature and precipitation data. For example, I'll show you the bioclimatic variables. So yeah, it include your climate layers such as mean diurnal range, isothermality, all the layers, mean temperature of the wettest, mean temperature of the driest quarter. So basically it covers like the entire range of climate parameters. But on all these 19 layers are derived from the basic temperature and precipitation data. So yeah, this is for the current / historical data. You can also download the future climate projections. So you have you have the future projections in multiple spatial resolution. So you have the time period for future projections ranges, which you can find here. And then if you just click on the linked in the link, so these are the different GCM, general circulation model data. We have a range of scenarios. These are the IPCC scenarios. We don't know that how much exactly our climate is going to be after like 80 years or like 50 years. So IPCC has come with a different projection system. SSP 126 is the most optimistic scenario, in which we will have the lowest carbon emissions and lowest temperature, as well as we have the highest. This is the worst climate scenario where the carbon emissions are going to be the highest. So yeah, if you want to do an analysis, you can just like opt for any climate change projection scenario, and it is available. There are different GCM models. All these GCM models might be closely related or or vary in their subclimate model depending upon their research group. So you can just, so
Yeah,
yeah,
just so
sorry.
sorry to interrupt. Just wanted to give you a heads up on time. It's 5:45. So can you let me know? You know, it's fine. Can you let me know how long will it take for you to wind up this one?
Oh, yeah. So there are only 3 more slides after
I guess
this.
5 minutes work. 5 minutes or so.
Sure. I'll try to wind up.
Take five
Yeah.
more minutes, and then we'll have a break, and then have your last session. Please.
Okay. Yeah. Okay. So yeah, you have like a variety of climate parameters from a variety of climate change scenarios and GCF model. You can also do an ensemble of these models. Okay. Um, Going back to the slide. And then you have Alaska Satellite Facility, which is also hosted by NASA. So these two, so Earthdata is another major website from where you can download the data from all the NASA satellites and additional data as well. The difference between Alaska Satellite Facility and Earthdata is not a lot, but there are few sensor data that are not available on Earthdata and it's available on Alaska Satellite Facility. So if you just click the link, it is partially hosted by the Alaska University. So yeah, similarly, just like USGS browser, you just select your study area. Sorry. You select your sensor. They also have data from SMAP, which provides you the global soil moisture maps. So yeah, they have data for a loss pulsar, which is also a SAR data, and then you just select your data. You just put your start and end date. And then once you, because I haven't put any date, let's see what it will like load all the tiles that are falling in that region. So you just click whatever tile you want to download. And then you come here and it will just, it's giving you the option to download the data. So yeah, it's pretty basic see, it's a part of Earthdata. So Alaska Satellite Facility is pretty basic to download. Going back to okay, yeah. So there's another website called, as I already mentioned, Earthdata. So if you just go to Earthdata, find data, go to Earthdata search, and this website has also like a fleet of platforms. If you want to download air-based sensor data, space-based, which is like which we all use most regularly, and then you have projects from like Sentinel. You have Sentinel 5 and 6 data here. And then you actually have a lot of data options here. Some of them are like airborne data. Uh, yeah, so again, you just like select your study area, select your time, select your data sensor, and just click on the options and it will download the data for you. I'm just showing quickly because I don't have enough time. The last would be the GADM data. You can download the country shapefiles from GADM. Just go to the area. So if you want to download spatial data using country, so let's say Afghanistan. So yeah, so it will show you the administrative boundary shapefile, and then you can just download it. So yeah, that's all for the data sharing portals. Is that okay, Gina? I guess we are finishing on time.